xShape is great for sculpting organic shapes from primitive sub-D surfaces, using the many available shaping tools and techniques. But in some cases, that is not enough to complete the physical product. The addition of more common modeling tools is often required. This is where the xDesign tools come into play. Extrusions, revolves, fillets, and chamfers can be used to add the more prismatic shapes required to complete the job. In this example, we'll see how fast and seamless it is to move back and forth between xShape and xDesign and to make full use of both 3D modeling apps. Note that if you are not familiar with xDesign, there is an entire learning path devoted to this topic. For you to complete the steps shown in this lesson, you must have both the 3D Sculptor role with the xShape app and the 3D Creator role with the xDesign app. Let's review what we have so far before we work to complete this model. In the Design Manager of the existing physical product, we have the standard 3 planes that all physical products start with, a point 1 feature. This was used to mark the 000 position where we place the primitive sub-D box. It is also hidden. A subdivision surface .1. This feature started out as the primitive sub-D box feature, as has been manipulated into a symmetric shape. Note that none of the individual manipulations are listed in the Design Manager as features, just the feature itself. And lastly, a knit surface.1 feature. This feature was added automatically when the subdivision environment, where you edit the sub-D surface, was closed. It knits the fully enclosed sub-D surface into a solid body. Let's check the size of the geometry now before we jump into xDesign. I'll click the Tools action bar. This toolbar contains a set of universal tools, including those for inserting pictures, materials, measuring, mask properties, draft analysis, section views, and 3D printing options. I'll click Measure and select the vertex on top of the part and another on the bottom. The default units for the physical product are millimeters, so the values for minimum, x minimum, y minimum, and z minimum distances are in millimeters. The overall height using the z minimum distance is close to 300 millimeters. Close the dialog. I want the body of this bottle, without the neck, to be about 200 millimeters in height. Also, the shape that we've already created should be maintained, so the entire bottle must be scaled by the same amount. To do this, we'll use the Scale by Distance tool. Let's click the Subdivision action bar and Scale by Distance. Scale by Distance and other tools in the Subdivision toolbar can only be used with sub-D surfaces. Note that the features in the Design Manager are suppressed and the rollback bar is moved back before Subdivision Surface 1 feature while editing. First, I'll drag the handles to vertices on the top and the bottom of the bottle, making the measurement as vertical as possible. The default scale uniform scales equally in all directions. Next, I'll type in 200, in this case millimeters, press Enter, and click OK. I want to check the size again, so I'll click the Tools action bar. When I click Measure, I am no longer editing the sub-D surface. It has closed the subdivision environment automatically, and the rollback bar has again moved, this time to after the last feature in the tree. The measurement between the two vertices is now very close to 200 millimeters. The solid body has been scaled down to the proper size. Now it's time to make the switch to xDesign and add some more geometry. Geometry that cannot be created in xShape. The switch between xShape and xDesign is a toggle, and it is just X. So to go from xDesign to xShape, press X. And to go from xShape to xDesign, it's the same. Press X. So let's try pressing X on the keyboard. A brief message says, transition successful, and the action bar menu change is the most obvious difference. There are also some automatic switches that you should be aware of. If you edit sub-D geometry while in xDesign, you will automatically be switched to xShape. If you edit geometry that originated in xDesign while in xShape, it will be edited while remaining in xShape. The spout will be created as a separate solid by extruding a circle to create a cylinder. After adding some draft, the actual shape will be a truncated cone. I'll create a new sketch on the XY plane. Using that sketch, I'll sketch a circle. We'll need to dimension the geometry and add a vertical relation to fully define the sketch. The extrusion will be 250 millimeters with a 1-degree draft. Don't worry if the extrude starting point and draft angle do not look correct. We will come back later to edit this feature. I'll click OK to create it. We're using the default Add option, so the feature is combined with the existing solid, the sub-D shape, and the result is a single solid body. Next, let's add a fillet at the edge where the two solids merge together. Fillets and rounds are created using the same command. xDesign decides whether to add or remove material. This is also a good chance to use the shortcut menu. I'll press the S key and the shortcut menu appears. It provides quick access to some of the most used options, like sketching, planes, extrusions, fillets, and patterns. I'll click Fillet. After selecting the edge, I'll use the 10mm fillet and click OK. The last xDesign feature we'll need is a shell feature to hollow out the bottle. Click the Features action bar in the Shell command. We'll use the default Inwards option to create the thickness of the shell inside the current body. The only face I'll select will have no shell. It's the opening at the top of the neck for the spout. I'll set the thickness to 2 millimeters. This is illustrated by the handle, the white ball, and the preview graphics. Click OK. We're not finished shaping the sub-D surface. I'll click the sub-D surface in the work area and click Edit Feature. This will do two things at once. Switch to xShape and enter the subdivision environment, editing the sub-D surface. Note that you can also right-click to access the same option. I'll select the vertices along the left edge and use Line Align to angle the rear edge of the bottle. After we exit the subdivision environment, the physical product rebuilds, but there is still some issues with the extrusion. Again, we'll simply edit geometry directly. I'll click the extrusion and click Edit Feature. I stay in xShape, but I can edit the extrude dialog. I'll expand the advanced portion of the dialog and change the start condition to From Offset. This moves the start point off of the plane by some amount, in this case 10 millimeters. For the blind distance, I'll reduce it to 220 millimeters. It also seems that the draft is in the wrong direction. I'll correct that as well. And click OK. Occasionally warnings or errors pop up when you make changes, and they'll need to be fixed in order to update the model. Usually they are fixed by editing the sketch or feature with the warning. I'll start with the first one in the Design Manager tree, the fillet, and edit the feature. It's missing the edge, so I'll select it and click OK. As often happens, fixing the upstream feature, the fillet, fixes the downstream features, the shell. Lastly, we can add some color by clicking on the name of the physical product and clicking Color. Let's use the Section View tool to see the shelled part in section. This is a temporary view that can be turned off at any time. Click Tools and Section View. Click the YZ plane to see the symmetrical section. Dragging the arrow in the robot allows you to move the section parallel to the cut, or rotate it using the arcs. Cancel the dialog. Lastly, let's take a look at the mass properties of the physical product. I'll click Mass Properties, click Body, and select anywhere on the geometry. Expanding dimensional information shows the volume, mass, and area, but much more information is available.